So friends, we are on second lecture of operation research, and that is we are trying to see what are the elementary methods that are available, like algebraic methods, then graphical methods, and then because we require for comparison what is the expanse of simplex method, why it should be used, what are the limitation of the present approaches. So that we will not be able to get it unless until we have full exposure to the how to handle the linear function. So this topic is simplex method part 1. Why I am calling part 1? Because it is preparing the background, it is preparing the algorithm for the simplex method, and the after this part 2 will be simplex method demonstration or illustration. Again the same example will be continued what we considered, and here at the outset I would like to thank the author of one of the publications which form the basis for demonstration of simplex method. I will give the specific name here in this lecture. So role of allocation and optimization in OR. It is well appreciated that whether it is resources that need to be optimized in terms of minimizing the resources and maximizing the profit, and so if we are having n allocations, n resources, how to allocate those resources so that the profit can be can be increased. Complexity, single and multiple objective function. So at present we will remain in the realm of optimizing the objective function in terms of profit. Okay. Same study can be extended to minimization of resources also, but since it can be well appreciated when we talk at the profit level, because this language is understood by each and everyone here. Then we have one approach is called graphical approach, where we try to look for the corners. Please remember this word corners. When we draw a figure, we see what are the perimeters that define the object or feasible area of the optimization problem. Then algebraic approach. We have been studying algebraic equations with two component, two variables, two equations. This will be a background. Why? Because we should know how we start from elementary level and go on to the simplex level. And if one of the case study later on I can give, it will be using a genetic algorithm approach for minimizing the risk or minimizing the maximizing the availability of the safety system. So otherwise the least I will do is I will provide with my lecture one of the complementary copy of this, but it is better I discuss in one of the lecture than project risk management. So this is the introduction for for this lecture. We'll have to understand lot of jargons that we use in operation research, definitions we have to see, and we have to understand what is the framework. So let us first understand the framework. What is so it is a scientific mathematical approach for business decisions. Now let us say the allocation problem is routine and non-routine ecosystem. So normally we will be limiting ourselves to the for routine and non-routine we have said, but we'll through the example which will be so elementary that we can say it is a routine thing, maximization of the profit, keeping in view the constraint on resources that I mean. So operation ecosystems. Operation ecosystem, there are many variables, and then finally we have to choose 2-3 variables which are competing in nature, and we have to choose 1, 2, 3, 2, 3, 1, their ranking in such a way that defines our organization's objective and goals. Project ecosystem has lesser routine activities. So, there are two ecosystems, operation ecosystem and project ecosystem. Project ecosystem, if we apply OR, the lack of data, variables uncertainty will be more compared to the if it is a operations ecosystem where the routine activities quotient is more compared to the non-routine activities are there. Allocation is nothing but risk reduction and risk optimization of raw material, labor, machine, while on objective function is of the profit. Then if we use maximization. So, optimization will mean something at one place, minimization, and optimization might mean for maximization, that is profit, or minimizing the risk. So, so here we call this type of problem as problem of allocation of whatever variables that we have in terms of optimizing a function. In this lecture, we will discuss resource allocation while maximization of the business bottom line, that is the profit, demonstration through a numerical approach. One numerical example we will consider, and through that we will try to demonstrate it. Now, Simplex, what is Simplex algorithm? How it works in various steps, step 1, 2, 3, 4, 5, 6, whatever. So, what is the basically idea is to present the algorithm, how it works. Okay. So, I am giving you the references which I have been using in this method, in this slide. At the same time, I am telling you certain characteristics. Simplex algorithm is well recognized and used in many places. In linear programming, the resources are referred as decision variable. Okay. And this I have picked up from a book called Rip J. and Levin Good using the Simplex method. It is a note actually, it is not a book, to solve the linear programming maximization problem, operation research, and the number is given, reports number is given. It is a 1998 document. And here I take this opportunity to thank Rib and Levin Good for explaining the concept of Simplex so vividly and so legitimately that my student will be benefited a lot because of this demonstration. Now, one note is here, Simplex in one dimension is a line segment, in 2 dimension it is a triangle, in 3 dimension it is a pyramid. You can draw for yourself this thing and you will find that how this Simplex problem have different shapes and all that, or the variables. Now, introduction and algorithm. There are terms associated, like we have been using objective function. What is objective function? Formulation enables maximization of the function. Maximization, I think I should say minimization also. So, yeah, so in terms of objective function, you have to optimize the, we have to maximize the function. The graphical format of Simplex find the most attractive corner of the feasible solution. If I have a trapezoidal shape, there are 4 corners A, B, C, D, and then Simplex in iterative process identifies the initial corner which is by some conditions, pre-decided conditions or graph coordinates, and then subsequently go for next best, and finally come to the best solution, that is our corner that is available. So, attractive corner, that is called, and the optimization is complete when we reach the most attractive corner. No, there is no corner which is more attractive than the corner we are calling feasible solution. Any linear programming problem having solution must correspond to a corner. It follows an iterative procedure for convergence to the optimal solution. Now, why I am calling iteration? Because you go on creating tables, and these tables are created by following the same procedure. For example, if I understood the first iteration, then other things are mechanical formulation of the same procedure which was used in the earlier step. Next step also will have with minor changes here and there, and which looks logical also. So that's why we call iterative procedure. Simplex usually start at one corner with extreme condition. Let us say what will be the coordinate of x0 y0 or starting point. If you make the 0 0, you get the 2 points, and from there, instead of looking in the space, we have there itself, and then we can iterate to the next corner and next corner. Then moves to the neighboring coordinate. When no one improvement can be, when improvement cannot be found, that is called the optimum solution. Okay. A moderate size, now this is the difficulty. A moderate size linear programming, with 10 variables and 10 equation can have 2 lakh corners. You can understand the complexity which goes on exponentially with this method. So graphical method, if you use, that doesn't, or even algebraic method will not provide a effective mechanism to solve this problem. For modeling a real time scenario, it is not possible to solve an LP problem and requirement of computer with a software. The only option is available. So let us assume at the outset that linear programming problem, especially simplex, have to be run on a computer which has been trained to solve the or which has got the algorithm to solve the simplex problem. Okay. Now simple illustration is there, which again I would say I have continued from the same report which I mentioned in my initial few slides, and I am not trying to make any change also, because the concept should go straight from the source, and there should not be any confusion. So that I have taken care, and my student even can access this report, and probably they can use this. These lectures will be something of a explanatory part actually. A furniture manufacturer produces wooden tables and chair. Okay. So it is a very simple example. The manufacturer or a carpenter company is producing table and chair. Unit profit for chair are 6 and for table it is 8 respectively. So chair's profit is 6. If he sells 1 chair, he gets $6. If he sells one table, if he sells one table, it is $6, and it is for chair is 8. Manufacturing the table and chair, two source, we require 2 resources, that is wood, that is board fit. Board fit means length of the board, 1 dimension they were given, because width is something non-specified parameter, and labor hour. So these are the 2 resources have been considered in this. So the 30 board feet and 5 hours are required to produce a table. So if I have to translate it into equation, and 20 board feet and 10 hours are required to produce a chair. Okay. So the constants are, there are only 300 board feet of wood and 110 hours of labor. Okay. So these are the constraints. This much only we have at our end, available at our end. Objective function is to minimize the profit. I think the problem is well understood. You can say 30 board feet and 5 hours are required to produce a table. So this is the resources required for table, and 20 people are required to produce a chair. Okay. Constant we said 300 and 110, and then objective function is to maximize the profit. If I have to translate this into a table, it's called tableau in simplex method, but okay. So table is characterized by a variable x1, chair is characterized by x2, then wood will be this one, labor will be this one. For earning the unit profit on table, and 20 board feet and 10 hours are required for profit of $8, and resources limited up to 300 and all. So we don't have more than that, and that is further, so our objective function is maximization of the profit. Z is the profit variable. It is 6x into 8x, 6x1 into 8x2. 6 profit 6 x1 into 8x2 is the profit, the optimal objective function here, and then objective function is 30x1 plus 20x2. It is on board feet, that is wood, that limitation less than or equal to 300 feet. That is, now we don't have more than that. And as far as the work hours, labor hours, 5x1 plus 10x2 less than 110, that we have over here. So, and x1, x2 are more than 0, that is non-negative. So, this is the problem formulation, and now we know that there are two variables x1, x2, and there are two variables x1, x2. But the problem is here inequalities are here. So, assuming that we remove the inequalities, so then it becomes a simple algebraic equation. But before that, if we plot these things, we have the wood graph is here and the labor line is here. Where the interaction occurs, it is called the optimum solution. So, now this is x1, that is table, and this is x2, that is chair. So, solving the linear problem equation properly, assume arbitrary solutions. Now, for z is equal to 48 and z is equal to 72, we have drawn these two lines. If we consider this as the profit line, and that has to be within less than this only, because for optimization we have to go up and up and up. Now, we have the equation line is equal to 6x1 at x2 is equal to 48, and the second equation is 6x1 plus 8x2 is equal to, two equations are there. So, if we solve these two, this is a profit line objective function, So, if we go like this, now that is a graph that we have drawn and we found the optimum point. Now, what to do for algebraic equation? For algebraic equation, we have to remove the inequalities. So, we have here, assuming that the equalities 1 and 2 have two equation and two variables, it can be solved for procedure application for algebraic equation. So, now if we put a is equal to sign, and this is a routine procedure for algebraic solving an algebraic equation, 30x1 plus 20x2 is 300, and 5x1 plus 10x2. You can see the previous equation. This is again further if we go down, these are the 30x1 plus 20x2 and all that. So, we go for it, and then finally we come back to our page, and we find that these are the two equations, and we solve this equation, and what we get is x2 is equal to 9, that means 9 chair and 4 tables. If we manufacture, then the profit will be 96. That is a point on the graph that is shown on the curve. It will be it might correspond to that. So, we have solved the problem. This is a optimal profit, $96 for 9 chairs and 4 tables. I think up to here there should not be any problem. When there are more than say 10 products and 10 algebraic approach may not be able to 10 equations rather may not be able effective. This difficulty we have discussed. So, algebraic equation have limitation. It is looking very attractive when we have only two variables, two equations. Okay, and here we have how we have handled the inequalities also, that also we have discussed. But when we go to the simplex method, there are way of removing these inequalities also. So, we will know where we stand actually. Okay. So, now let us see simplex method procedural elements, how we solve the same problem using simplex method. So, in this lecture, the objective is to demonstrate the salient feature or various steps involved in the simplex method. In the next lecture, we will handle this. So, first is develop the tableau. Now, tableau we have developed, but you have seen here add slack variables. We have added a new term we are getting in here, slack variable for wood SW and slack variable for labor, that we have added. Why we have done that? Because we wanted to remove the inequalities. Okay. Now, this table we have developed with doing this. Now, there is one more term, basic mix of the table of variables that we have over here. And then unit profit is how much? See, per unit profit at present it was 6 and 8 that we have seen. 6 and 8 that we had seen there. And if x1 is equal to 30 in one equation, second equation 5, x2 is equal to in first equation 20 and 10, then SW is equal to, see, 0 we are assigning randomly, so that we can evaluate the other parameter by keeping value as it is 1, and solution is 300 and 110. So, this is basically the first tableau that we have developed as part of this one. Now, what will happen is, when the improvements in the tableau will be shown over here, and there is a criteria. The bottom case reverse, sacrifice and improvement, that form basis for level of optimization. So, these two will tell us, especially improvement will tell us whether we have reached the optimization or not. Now, find the sacrifice and improvement row. Okay. How to find out? The value in the sacrifice row indicate what will be lost in per unit profit by making a change in resource allocation. So, what will be lost if you make per unit profit in this thing row, then what will be, and then in the improvement row, value in the improvement row indicate what will be gained. So, here it is what will be lost per unit change, here it is will be gain in per unit profit, making a change. So, one is showing sacrifice, other one is showing improvements, and from here we will get whether we have optimization. So, this is the second step, that is identifying the sacrifice and improvement row. At present, a value of 0, 0 has been assigned, and 6, 8 we have copied from their unit profit, we have copied from their top. Okay. And varying these values will tell us the optimization level whether we have reached. Now, step number 3, apply the entry criteria. This is very identifying the entry criteria and exit criteria are the two key operations that we have to understand. Of course, when we will please note that if you do not understand these things very clearly, there is an opportunity to learn when we have mathematical treatment to the same problem. You will understand that, but try to grasp as much as possible. That means, so in the next lecture we can go with a very sound understanding of simplex method. The entering variable is defined as the current non-basic variable. That will, now again we will understand the definition of non-basic variable, basic variable also, but do not bother about that. That will most improve the objective in its value is increased from 0. Presently it was 0. So, from 0 how much it will increase, that will show what is the improvement in the objective function. Objective of this step, that is entry criteria. We are working on entry criteria on the table. Objective of this step steps is to find the entering variable and mark the top of the entering variable. Now, like if I have to go to my previous slide, see, x1 can be entry variable. Okay, the criteria will know. So, we will put an arrow here. Okay. Exit variable, if it is SL, we will put a arrow here, or if it is X2, we will put a arrow down, and then we will exit variable SW will put a arrow here. That criteria also we'll see how we are going to do that, but this is going to happen in the table later on as you go ahead. When no improvement is found, then optimal solution is reached, and that will be indicated very clearly in improvement row, that is the last bottom row of the table. If no positive appears in the entering variable column, that implies that one or more constraints are unbounded. That means as unlimited resources, the unbound solution indicates the problem was not formulated correctly. So these two are caution measure. That means if you have not formulated the problem correctly, there will be unbounded and unlimited resource will be coming in there. Now similarly, like entry criteria, we are going to define exit criteria also. Estimate the exit the exchange ratio. This is one more feature, very important feature of Simplex. So we have to estimate the exchange value using the pivotal value and then resources divided by resources, and you will get it. And exchange coefficients. So first comes exchange coefficient. The significance of exchange ratio is it identifies the variable with limited resource or consume faster. Okay, so resources which are limited or they consume faster. 4.2, identify the limiting resources with criteria lowest non-zero non-negative value. I have marked here red because this will be using when we use a numerical problem. Identify the limiting resources with criteria lowest non-zero non-negative. The basic, that means some numerical figure should be there, it should not be negative. The basic variable in this row becomes the exit variable. So now you identified the exit variable also. You identified the entry variable also, you identified the exit variable. Mark the exiting arrow with a arrow pointing to the left. So I showed you on the slide what we have to do. So this is a very important operation. This is a key to solving the simplex problem. Now 5 is construct a new table. Now based on the changes that we got, we are constructing the new table. Construction of new table is initiate the process or looking for a new corner. That means we don't get the optimum solution there, and it did not meet the criteria of improvement also. So we go to the next corner. Here one variable will enter the basic mix and will leave the basic mix. So one will enter, another will go from the basic mix. What is basic mix? Don't worry, we will be discussing this. And become a non-basic variable. The operation of entering and exit variable is called pivot. So where they are crossing, entering and exit variable, where they are pointing or crossing, that becomes the pivotal point. Okay. So like it could be SW and X1 interaction junction. It could be SL and X2 interaction, whatever combination of the pivotal point. The simplex method is made up of sequence of such pivots. That pivot identifies the next corner to be evaluated. That's why I have put it in mark. These are the turning points in simplex method. New basic mix always differs from the previous basic mix. Yes, it will not remain same because the entry and exit variables are different. One variable, that is exit variable, is being replaced by a entering variable. Okay. Construction of tablets, replace the existing exiting variable in the basic column. So let us say X1 will replace SL or SW, okay, while remaining in the place with new entering variable. The basic mix variable remains in the same. Change the unit profit or unit column with the value of the new entering variable. Compute the new row value to arrive at the new set of exchange coefficient. So again exchange coefficient, existing variable, and repeat the step 2 to 5 till you arrive at an optimum solution. So these are the basic algorithm for simplex method. I am sure many of you would have got lost into the technicalities and terms used mix variable, mix of this thing. So it will get clarified later on when we take the new next lecture on implementation of simplex method using some numerical technique. So yeah, we have demonstrated we have discussed the algorithm of the simplex method, and we are ready for the next numerical problem. Thank you.